Greetings everyone! Today we're going to explore polynomial division using synthetic division. You'll want the handout provided to you in class, and of course a writing utensil in your notes. For the handout provided to you, make sure you fold it like a book, and you will need to title it yourself Polynomial Division, but identify synthetic division so it's different than our previous notes. Synthetic division is a shortened version of long division, but it only works when dividing by a linear expression, such as x plus 3 or x minus 1. So key thing here is, a lot of students think that synthetic is so much easier than long division, but it's very limited. You can only have a binomial with an exponent or degree of 1. So for example, I can't divide by an x squared plus 1. Therefore, I'm limited. Whereas with long division, we do not have those restrictions. It works with any type of divisor. Let's take a look at example 1. First, identify your dividend, and then we also have our divisor. Unlike long division, you're not going to use the entire factor. You're going to use the factor's solution. We've been finding factor solutions for the last 2 units. To start off, set it equal to 0 and get x by itself. For synthetic division, you actually use an upside down division bar. Your solution goes on the outside, and your coefficients go on the inside, meaning your 1, your -2, your -8, and your -35. These are all the coefficients followed by the constant. The first step is just going to be to bring down the first term. Then you multiply the 5 by that first term. Now, unlike long division, in synthetic, you add the terms. So I always think if I was to extend these lines, it would make a plus sign. So I always remember it that way, that it's addition when you do synthetic division. So in this case, when I add those terms, I end up at +3. Then I need to take 5 times 3. I get up to 15. Add those terms, so -8 plus 15 gets me to +7. Then I take 5 times 7, gets me to a +35. Add those terms, and I end up at 0. Now, we have these 4 numbers, and we have to decide how do we write that quotient back as a polynomial. So we took it out of polynomial form, and now we need to put it back into polynomial form. This order you'll want to make note of. This first term on the right is always your remainder. And if we go in order from right to left of a polynomial in standard form, this next value would be our constant. The next value would be our x coefficient. And this term would be our x squared coefficient. If you have more terms, you would just keep going, x cubed, x to the 4th. So if I want to write my answer, I would end up with a 1x squared plus a +3x plus a 7. And in this case, I don't have a remainder that I need to write out. So that would be my quotient. Let's take a look at example 2. First, start off by finding your solution. We're going to use -1 as our divisor. Set up your upside down division bar with a divisor of -1 on the outside and all of your coefficients in order for standard form on the inside. First step, bring down the first term. We have a 1. -1 times 1 is -1. Add those terms together. 3 plus -1 is 2. -1 times 2, -2. 5 plus -2 gets me to 3. So if I write these out, again, maybe label them for the first few times until you get used to it. This will always be your remainder. Next will always be your constant. And then we have our x coefficient. So if I write my final answer for my quotient, I am going to have a 1x plus 2. And I have a remainder. Remember, remainders, we add on the piece that does not divide in evenly. So we have 3 over our divisor of x plus 1. So this remainder is the same as long division. Okay, so that should, all of our answers, no matter what form of division we use, should look the same. Let's take a look at a little bit longer question. First, read through that dividend and see if you notice anything. We've got an x to the fourth, an x squared, an x, and a constant. I'm missing an x cubed, so I'm going to put in a 0x cubed. Just like long division, you have to account for that missing term. So let's get started. We're going to write every coefficient in order, followed by the constant. We want to use our solution of our divisor. So in this case, x equals 3. First step, bring down the leading coefficient of 1, multiply your terms. Add them together. Take your new value, 3 times 3 gets me to 9. Add those together, we get a negative 1. 3 times negative 1 gets me to negative 3. Add those together, we get a negative 1 again. Multiply 3 times negative 1, we get negative 3. And that gives us a remainder of 0. Again, if I label, I have my remainder, I have my constant, I have my x coefficient, my x squared coefficient, and in this case, an x cubed coefficient. So if I write out my quotient, I have a 1x cubed plus a 3x squared minus a 1x minus a 1. And I don't have a remainder, so I don't need to put anything at the end. You'll notice as we go through these that very often our degree of our quotient is one less degree than our dividend. Just keep an eye out and see if that's a continuous pattern. Don't rely on it yet, but let's make notice of any patterns like that. All right, example 4. Notice how this is written. It means exactly the same thing, whether you write out division with a division symbol in between your polynomials, or if you use a division bar, they mean exactly the same thing. So again, the first thing I want to set up is my synthetic division bar. My divisor is my solution of my factor, so I'm going to use a 2. Then I have a coefficient of 1, negative 2, 3, and a constant of negative 4. Start off by bringing your first term down. 2 times 1 gets me to 2. Add those together, I get 0. 2 times 0 is 0. 3 plus 0 is 3. 2 times 3 is 6. Negative 4 plus 6 is 2. Let's label from right to left. You'll always have remainder, constant, x coefficient, and x squared coefficient. So in this case, I have a 1x squared plus 3. I don't need to write 0x because it's 0. But then I also have to add on my remainder, what does not divide evenly, and we have 2 over the divisor of x minus 2. So make sure that you understand the concept of long division compared to synthetic division. Remember that synthetic division, you have to have a divisor with a degree of 1. Okay, that's very limiting, whereas long division always works. In this unit, I will ask you to perform both types of division. Later on, what we're going to do is we're going to extend this division into its full purpose. So right now, we're kind of just doing the algebra behind it. Eventually, we'll get into the why. Why are we doing this? How is it useful? If you have any questions, make sure you visit with me. But until then, we'll see you next time.